Hello everyone, welcome back. Okay, so we're going to move on to page 2 of our notes, but before we get into it, little disclaimer. We're going to now be looking at how math can be a tool to manipulate equations that you will see in physics and how they can help to interpret the world around us. So I don't want you to get overwhelmed because all of a sudden you're going to see words like acceleration and distance and velocity, as well as like amps, current, resistance. And so I'm not expecting you to understand all that right now. All I want to do is to show you how we're going to use these mathematical tools throughout the year. Okay, so take a deep breath. You're going to do awesome. You're not going to get overwhelmed by all the physics words and examples because we're going to talk about it throughout the year. So just focus on how we're using the math. Okay, all right, let's get into it. So here is a physics equation that you're going to encounter later in the year. And the first thing that you'll often do with these kinds of equations is you're going to recognize what the variables mean. Because in this case, the v variable stands for velocity, a stands for acceleration, and x stands for distance. We also have this weird Greek letter delta. And delta in this case, and in most sciences, it means a change in or final minus initial. So if I were to say this equation in a sentence, I'd say velocity squared plus 2 times by acceleration times by the change in the distance. Okay? And what's so great about this online video and environment is you can always pause and rewind and listen to it again. Okay? So that's how I would form that into a sentence. So what does this change in mean? So delta, change in, is the final value minus the initial value. So if I'm looking at the mathematical expression of delta x, what I mean is my final distance minus my initial distance, or x final minus x initial. All right, moving on. We're also going to be looking at circuits this year. And when we deal with circuits, you're going to be seeing values of voltage and current and resistance. Okay? You'll also notice as you go through the year, a lot of these units are called derived units, which means they're multiplication or divisions of other units combined. And sometimes we rename them. Like a newton is a kilogram meter per second squared. And so in this situation, a volt is an amp times by an ohm. Okay, so let's see what we have here. The equation V equals IR. Okay, what does that mean? Voltage is equal to current times by resistance. So in the equation, V equals IR models the flow of electricity in this simple circuit. So let's interpret the meaning of the equation by translating the symbols to a sentence, like we just did. Well, voltage is going to equal current times by resistance. Okay. What is the resistance of a light bulb that has 0.75 amps current when plugged into a 120 volt outlet? Right, now, anytime you come across the problem, you should be following these 3 steps. You should analyze the problem, and then you should solve for the unknown, and then evaluate the answer. So when we analyze, we want to list our knowns and our unknowns, what we're solving for, and also look and see which equation we want to use. So I'm going to analyze this, and I'm going to go, okay, I have amps, which is current, so I is going to equal 0.7.
Mendenhall, if you're here, line 1 is for you. Shelley Mendenhall, line 1 is for you.
Okay, I've already tried to film this video like 4 times, so we're going to keep going. So 0.75 amps is our current. And when we plug this in, it's 120 volts. So our voltage, 120 volts, but a volt is the same thing as an amp ohm. Okay, so you could also say 120 amp ohms. Right. Now, what's our unknown? What are we solving for? See the resistance. So we want to know R. And we're going to use the V equals IR equation, but we need to rearrange it to solve for the resistance. We need to get resistance by itself. So in order to do that, these two terms are multiplied together. So we're going to divide by I to both sides. Here it cancels. So our new equation is R is equal to V over I. Okay? So R is equal to V, which is 120 amp ohms, and we're dividing that by I, which is 0.75 amps. Okay, plug that into your calculator, and we're going to get a value of 160, but 160 what? What are the units attached to this? Well, we can use these same mathematical tools to look at the units as well. So I see I have amps and ohms, and then I have amps. So amps is on the top and the bottom of my equation, so they cancel, and I'm left with units of ohms. So now let's ask ourselves, we solved for the unknown, now let's evaluate this answer. Let's see if the units that we expressed with this is resistance, what we're looking for. Resistance is in ohms, and so that's a good way of evaluating your answer and seeing if you followed through the math correctly. All right, so now we have a light bulb with a resistance of 50 ohms. Oh, here, a little typo I want you to change. So an ohm has an interesting Greek symbol with it. It's kind of shaped like a horseshoe. Okay, and so we're going to use that symbol now. Is used in a circuit with 9-volt battery. What is the current through the bulb? All right, we're going to analyze the problem first. And when we look at this, we have 50 ohms of resistance. And we have 9 volts, which is our voltage, right? And don't forget, we're going to separate that into amps and to ohms. And then we also, no, that's our two knowns. What's our unknown? Let's see, what is the current? So we need to know I. Don't know our I value. Okay. The last part of analyzing is choosing which equation we're going to use. So V equals IR. We're solving for I, so we'll rearrange that equation to get I by itself. So V divided by R is equal to I. And now we'll plug in our values. We'll solve for the unknown. So we're now on to step 2. So our voltage is 9 volts, but let's use our derived unit for that, which is amps, and then ohms, so our new omega symbol, and then that's divided by R, which is 50 ohms. Okay, so we're going to take 9, and we're going to divide that by the 50 value. I wrote 550 value, and that's going to be 0.18. But what's our final units? Let's use our mathematical expressions and skills. So we have amps, ohms over ohms. So ohms cancel, and we're left with amps. All right, last step, evaluate the answer. A good way of doing this is looking at the units and seeing if it's the ones that we wanted. We were solving for current, and current should be in amps, and our final answer is in amps. So that's a good way of evaluating that. All right. Now, an object accelerating from rest will reach a speed of v in an amount of time as described by this formula here. Velocity equals acceleration times by time. What is the acceleration of a bike rider who accelerates from rest to 7 meters per second in 4 seconds? All right, that's a lot of information. Let's break it up. We're going to analyze the problem and see what we have. We have meters per second, which is kind of like miles per hour, a distance over a time. So that's going to be our velocity. Velocity is going to be 7 meters per second. And then our time, all this is happening in 4 seconds. And let's see what's our unknown. What is the acceleration? So we want to know A. And then we're going to decide which equation we're going to use. And we're going to use the velocity equals acceleration times by time. Okay, we got the first part done. We analyzed the problem. Now let's rearrange the equation to solve for the unknown. So we need to get acceleration by itself. So we'll divide both sides of the equation by t. So acceleration is equal to velocity divided by time. Okay, let's plug in our values. Our velocity is 7 meters per second, and our time is 4 seconds. And so we get 7 divided by 4, 1.75. Make sure you're following along. You have your scientific calculator out and you're running these numbers so that when you get to the exam, you're not worried about how to run your calculator. You're practicing now. Right? But what's the units? Let's think through it. We're taking meters per second and we're dividing it by seconds. Let's rewrite this in a way that's easier for us to conceptualize. So meters per second, and we're going to divide by seconds. We're working with a fraction, so let's put the other value over 1. Okay? Dividing by a fraction is the same as multiplying by the reciprocal. So this is the same as meters per second times by 1 over seconds. Nothing cancels. And so we are left with meters per second squared. That's our units. And we're looking for acceleration. Well, what is the units of acceleration? We haven't talked about that yet. But if we look at the next problem, we see how long will it take a scooter to accelerate at 0.4 meters per second squared. So here it kind of confirms to us that yes, we did get the right answer. The other nice thing with evaluating is if you can put it in the context of your real life, you can think how far a meter is and how long a second is and say, is this number reasonable or is it unreasonable? Okay. All right, number 3, I want you to do it on your own. Work through the problem in a similar way, analyze, solve for the unknown, evaluate your answer, and I will tell you that the final answer for this, number 3, is 10 seconds. Okay, so work through it and see if you get that final answer of 10 seconds. Okay, page 3.